Good day everyone. Today we're going to discuss quantifiers. What is quantifiers? In English, these are the words such as all, some, many, none, and few. So, these type of words are used to express some property which is true over a range of subjects. So basically, these words such as all, some, many, none, and few are called quantifiers. In mathematics, these important quantifiers or the two important quantifiers are commonly used in order for us to create a proposition from a propositional function. And the two important quantifiers are universal quantifier and existential quantifier. So, the two types of quantifier is first, we have the universal quantification. So, a predicate is mahimo siya na true for every element in the domain. So, in every element it should satisfy so that it would become true. In the existential quantification, there should be at least one or more elements in the domain that is present for which a predicate is true. So again, from the word universal, it means that every element in the domain should be present. So dapat yaon siya para mahimo siya na true. And then sa existential is there should be one or more nga elements in the domain for which a predicate can be true. So, there are two quantifiers. First, we have the existential quantifier. So, the symbol for the existential quantifier is just like a reverse letter E. So, pinabaliktad siya nga letter E. It reads, there exist. So, makita na to na A ang gaon na exist. And then, sa universal quantifier is pinabali siya na letter A or apple. So, it reads for all. So, again, sa existential quantifier, ang iya symbol is pinabaliktad na letter E, and then sa universal is letter A. So, unhon siya pagbasa. Sa letter sa existential is it can be read as there exist. And then sa universal is it can be read as for all. So, dapat from the word for all, dapat yaon tanan, and then sa existential, there exist. So, as long as yaoy isa, or duha, or damo, so it can then be true. For example, in this shown image, so here in the universal, so we have for all x of p of x, so it means that all elements satisfy. So makita na to that everybody are wearing their hat. So dapat is gasuot sila tanan ng hat para mahimo siya na universal quantification. And then here's existential. So it means that at least one does. So makita na to na as long as there is one among the four men nga nagsuot og hat, so it would be true. So even if may isa nga di nga wara gasuot og hat, however, we can see na yaoy tulo nga gasuot ng hat. So from the word existential, as long as there is somebody nga ga-exist, so mahimo siya na true. So again, the difference between universal and existential, so sa universal, all elements should satisfy. And then sa existential is at least one yaon para mahimo siya nga true. So, the universal quantification, so definition, the universal quantification of p of x is the statement p of x for all values of x in the domain. So the notation for all x of p of x, it denotes the universal quantification of P of X. So dapat whatever the value of P of X is should be true for it to become universal quantifier. So again, this is the symbol for universal quantifier. It is called as the universal quantifier. So how do we read it? So for all x, so again, we will read it as for all x of P of X, or for every x of P of X. So an element for which P of X is false is called a counterexample of for all x of P of X. So for example, we have a universal quantifier. For example, we have everybody loves pizza. So from this word, everybody, it shows that it is a universal quantifier because again, it satisfies that all, so all, tanan, from the word everybody. However, kung mulaong kita nga di, however, someone don't like to eat pizza. So, someone. So, for example, mulaong kita, however, someone do not like to eat pizza. So, that is what we call counter-example. So, gi-counter niya ang word na imbis true na siya, yahimo siya na false. Tungod kay gi-counter niya nga ayaoy baya isa dili ganahan nan pizza. So, mahimo na dayon siya na false. Because, again, ang universal quantifier, it should satisfy all element. So, dapat tanan para mahimo siya na true. So, the universal quantifier for all x of P of X is true when every instance of x makes P of X true when plugged in. Like taking conjunction or and. So, over entire universe. So, for all x of P of X, so dapat Px1 and Px2 and Px3 and so on and so forth at to Pxn. So, when we say and, so di ba ang and is dapat both elements are true. So, both are true for it to be true. So, just like how a universal quantifier is. So, dapat ini siya is true, ini sub siya true, ini sub siya true, and so on and so forth up to xn dapat true siya. Because when someone because if one of these element is false, so for example, gi-counter example na to siya, gihimo na to siya na false, so dili na nato siya matawag na universal quantifier because yaoy one element nga ga-counter sa iya nga himo siya na false. So therefore, para matawag nato siya as a universal quantifier, dapat all elements x1 up to xn are true for it to become true or for it to become a universal quantifier. So, for example, we have here, let P of X be the statement x plus 1 is greater than x. So, what is the truth value of the quantification for all x of P of X where the domain consists of all real numbers? So, uno na to pagkabalo, based on this given statement that P of X are true or for all, makasatisfy siya. So, how should we do it? So, for example, our x, we have Px. So, if our x is equals to 1, we have 1 plus 1 is greater than 1. So, we have 2 is greater than 1. So, our x1 therefore is true because we know that 2 is greater than 1. So, what if our P is x with our x now is equivalent to 2? So, we have 2 plus 1 is greater than 2. We have 3 is greater than 2. So, this is true. So, next, we will try with 3. So, we have 3 plus 1 is greater than 3. So we have 4 is greater than 3, so true. So based on these given answers, so magkadako ang value sa x, so true ang iya answer because biskan ato gamiton is 100, makita na to na using the incrementation of 1, so plus 1, so mas dako gayud iya value compared sa gihatag na value sa x. So therefore, based on the solution, it can be stated that because p of x is true for all real numbers x, the quantification for all x of p of x is therefore true. So makita na to based on the solution that it is true. So we have another example. So let q of x be the statement q is less than 2. So what is the truth value of the quantification for all x of qx where the domain consists of all real numbers? So mag-start kita nan ato qx is equal to 1. So 1 is less than 2. So true because gamay ang value ng 1 compared sa 2. So q, our x now is 2. So 2 is less than 2. So makita na to na it is false because they are of the same value. So dapat 2 is equals to 2. So we will try another qx3. So we have 3 is less than 2. So mas gamay ba ang 3 compared sa 2? Di ba dili? So this is false. So therefore, based on the given na solution, it can then be stated that this statement is not universal because every element is not true. So makita na to, sa first is we have true and then false, false na dayon siya. Based sa definition sa universal is it should be true to all elements for it to be called universal. So qx, so again, qx is not true for every real number x because, for instance, makita na to kainan ang value sa q3 is false because 3 less than 2, dili yun siya pwede because greater ang value sa 3. So that is x is equals to 3 is a counter example. Makita na to, nagi-counter example siya. So yahimo na false for the statement for all x of qx. So thus, for all x of qx it is false. So false siya. So another example, what is the truth value for all x of px where p of x is the statement x to the power of 2 is less than 10 and the domain consists of the positive integers not exceeding 4. So what are those numbers not exceeding 4? So we have 1, 2, 3, and 4. Okay, ang word not exceeding. Pero mulaong siya not exceeding 5. So 5 sa ba na to taman nga di. However, ken laong sa niya not exceeding 4. So sa 4 da kita kutob. So what if ang value sa ato x, first value na nato x is we have 1. So 1 raised to the power of 2, 1 dagi hapon is less than 10. So true siya. So what if ang value na pod ko man is our x is equals to 2. So 2 raised to the power of 2 is less than 10. So 2 raised to the power of 2 is 4. So true siya. Next, the value of 3. Our x is equal to 3. We have 3 raised to the power of 2. 9. So we have mahimo siya na true. And then last is we have our x 4. So 4 raised to the power of 2 less than 10. So, 16 less than 10 is false. So, therefore, based sa ato solution, there is a counter example which is false. So, ang x1 nato true, x2 true, x3 true. However, pag abot nato sa x4, we have false or we have a counter example. So, therefore, based on the given statement, the statement for all x of p of x is the same as the conjunction. So, we have P1, P2, P3, and 4 because the domain consists of the integers 1, 2, 3, and 4 because dili mo exceed sa 4. So, because P4, which the statement 4 squared is less than 10 is false because 16 less than 10, so mas dako sa gayud ang 16. So, yahimo siya na false. It follows that for all x of p of x is false. So, this is false. So, what is the truth value of for all x of p of x where px is the statement x squared is less than 10 and the domain consists of the positive integers less than 4. So kaina, ang gilaong niya is not exceeding. Wara di dapat mo lapas ng 4. Kuman ang giayo na sab niya is less than 4. So since less than 4 sa siya, we will have 1, 2, and 3. Na nga sa dili na nato iapil ang 4 because from the word less than, mas gamay sa 4. So dili nato apilon an 4. So, we will try to test to know whether this is true. So, if our x1, we have p x1. So, our x is 1 squared less than 10. We have 1. So, true. And then p x2, we have 2 less than 10. We have 4. So, we have true. And then p x3, we have 3 raised to the power of 2 less than 10. We have 9 less than 10, which is true. So therefore, as we can see, so since all of the elements satisfied, so true siya tanan, so it can then be stated that for all x of p of x, it is true. So, the statement, so because the domain consists integers of 1, 2, and 3. So, therefore, for all x of p of x, it is true. So, that is how universal quantifier works. So, dapat, for all elements, is it should satisfy for it to become true. So, the existential quantifier, so, there exists x, so again, pagbasa ng ini, there exists. So, there exists x of p of x is true. So, when there is an instant that can be found, which when we plug in for x, makes p of x true. So, like taking this junction, ang ginatawag nato na OR, over entire universe. So, as long as there would be one nga makasatisfy for it to be true, so pwede siya mahimo nga true. So, let P of x denote the statement x is less than 3. What is the truth value of the quantification? There exists x of P of x where the domain consists of all real numbers. So, because x less than 3, x greater than 3 is sometimes true. For instance, when x is equals to 4, the existential quantification of p of x, which is there exists e of x there exists x of p of x is true. So as long as yaoy makasatisfy sa iya for it to become true. Kaya kung mulaong kita, for example, ang value na nato p is equals to 1, so makita nato na 1 is less than 3. So this is false. And then p 2 is less than 3, false gihapon siya. p 3, so we have 3 is greater than 3, false because this should be equal. And then p nato 4, so 4 is greater than 3, so mahimo siya na true. And then p5 nato, so 5 is greater than 3, true. So makita nato na even though isa lang siya ka true, so isa, duha, or magkataas siya, true na sa siya yaon. So makita nato na even there should be at least one or more nga element for it to become true. So again, that is existential quantifier. So what is the truth value of there exists x, p of x, where p of x is the statement x squared is greater than 10, and the universe of this course consists of the positive integers not exceeding 4. So di mo lapas ng 4. We have 1, 2, and 3. So for example, our x is equals to 1. So 1 raised to the power of 2, 10. We have false. And then p, so we have 2 greater 4. We have 4, false. So p 3, so 3 squared, so 9 is greater than 10, is false. So since waray ato yakita nga di na true, so yadi pa 4, because ang word is not exceeding. Wala siya galaw na less than, not exceeding. So p 4, we have 4 squared greater than 10, 16. So true. So may ato yakita na isa nga true nga di. So we can say that this statement p of x is true because there exists at least one nga true. So makita na to, which is the statement 4 squared is greater than 10 because 16 is greater than 10, so therefore this is true. So it follows that there exists x of p of x, so therefore it is true. So the precedence of quantifiers, the quantifiers for all and there exists have higher precedence than all logical operators from propositional calculus. For example, for all x, p of x, and or q of x is the disjunction of for all x of p of x and q of x. In other words, it means that for all x of p of x or qx rather than for all dili siya pwede na mahaod ini. So dapat is haod da ini siya and haod ini siya. So we have here the De Morgan's revisited or De Morgan laws for quantifiers. So translating from English into logical expressions. So we have here the statement, express the statement, every student in the class has studied calculus using predicates and quantifiers. So, una buhaton. First, we will rewrite the statement so that we can clearly identify the appropriate quantifiers na to gamiton. So, i-rewrite na to ini na statement. So, for every student in the class, so for every student in the class, that student has studied calculus. So for every student, so makita nato na this is a universal because it satisfy. So for every, from the word for every, so universal quantifier. Next, so yahuman na nato siya pag rewrite. So now we introduce a variable x so that our statement becomes, so i-refer na nato ang variable x to the student. So for every student x in the class, x has studied calculus. So again, first at ubuhaton is i-rewrite na to ang statement. So after rewriting is magbutang kita ng variable referring to that student. So makita na to na for student x, and then gikan sa that student i-refer na nato siya as x. So continuing, we introduce the predicate c of x, which is the statement x has studied calculus. So consequently, if the universe of this course, so for x consists of the students in the class, so makita na to for x in the class, so ang every student has studied calculus. So therefore, we can state this statement. So for every student in the class, so it has studied calculus. So for all x of c of x. So again, ang c of x na ini is inin has studied calculus, and then for every student, this would be our a of x, and then this would be our c of x. So this would be our logical expression. So this would be. So there are other correct approaches, different domains of discourse, and other predicates that can be used. So for example, if we change the domain to consist of all people, we need to express our statement as, so for example, so yaon na, ang gihatag na nato kaina na statement is, every student in the class has studied calculus. So amo da ang gihatag na statement. So what if dungagan nato siya na if person X is a student in this class, so unhon na nato siya kuman. So we will add another representation. So we will have if S of X, so it will represent the statement that a person X in this class, our statement can then be expressed. So makita nato nga yaoy word nga then. If then nga word. So bantayan niyaon siya. So yaoy if then na word. So di ba ang F then, ang iya symbol is an arrow. So if then. So for example, we have if person X is a student in this class. So kung yaon kuno na student is yaon sa class, so therefore study siya given calculus. Okay, ang gilaon sa for every person X. So since this representation is of S of X, so we will have for every X of S of X, and then dili kalimtan ang if then. So we have if then C of X. So therefore, this will be our statement or our logical expression. So another example, so someone, so kuman, someone na. So this would be an existential quantification because someone, pwede siya true, pwede false, pwede isa, pwede duha, pila, biskan pila, because someone sa. So someone in your school has studied calculus. So, let S of X, so, again, imuyaon siya first is i-paraphrase. So, let S of X be the propositional function. X is in your school, and C of X be a propositional function. X has studied calculus. So we have there exists X, S of X, and or C of X. So this would be our solution or our statement. So again, when there is a word, someone, or somebody, as long as it would not refer to all, so it would become an existential quantifier. So always remember that. So since we are finished with the quantification, now we will go with the sets and subset. So what is a set? So set is an organized collection of objects, things, or symbols with common characteristics that are clearly defined. So when you say organized collection, giisa siya from the word nga set. So the individual objects in a set, so ang individual objects sa set, kay ginatawag nato siya na members or elements. So there are 3 ways para ma-describe nato ang sets. So first is, we have listing the elements. So usually, amo gyud inian kasagaran nga ginagamit. So the set can be defined by listing all its elements separated by commas and enclosed with braces. So for example, we have here the set of P. So ang elements ngayon sa iyaha are B, E, M, S, and Y. Makita na to na they are separated by comma and enclosed by a braces. So we have the braces. So again, this is our set, and then we have its elements. So a set can have an elements composed of numeric or alphabet. So pwede siya alphabet, pwede numeric, either capital or small letters. So it depends. So first way to have the elements is first we have the listing the elements. So usually amo ini ang kasagaran makita na way of declaring a set. So we have P equals to B elements B, E, M, S, and Y. So next is describing the elements. So the set can be defined where possible by describing the elements clearly in words. So for example, E is the set of multiples of 5. So i-describe niya na, for example, makita siya na E is equals to 5, 10, 15, 20. So, pwede dahil niya tawagon na E is the set of multiples of 5. Kaya makita sa na to ng 5, 10, 15, 20. It is a multiples of 5. So, next, M is the set of vowels in the English alphabet. So, for example, makita niya M, we have A, E, O, O. So makita sa niya nga this is a vowel. So, therefore, it can then be stated or ma-describe nga, those sets is a set of vowel in English alphabet. And then Z, so we have Z is equals to January, February, March, April, May, up to December. So, based sa gihatag na set, so it can then be described na Z is the set of months of a year. So first, again, we have listing the elements. So ilista nimo siya. And the next is we have describing the elements. So based on the given sets, is pwede nimo siya ma-describe. And the next is description by set builder notation. So the set can be defined by describing the elements using mathematical statements. This is called the set builder notations. So for example, we have x is an element of E such that x is a multiple of 5. So for example, such that x is a multiple of 5. For example, amo inya itong mga values sa x. So next is x is an element of m. So x is an element of m such that x is a vowel in the English alphabet. And then another example, so x is an element of z such that x is a month of the year. So again, in describing a set, so there are 3 ways. First, we have the listing the elements, amo ini usually ang ginagamit. And the next is gina-describe ang elements based on the given set. And then lastly is description by set builder notation. So set membership and notation. So we should describe a certain property which all the elements x in a set have in common so that we can know whether a particular thing belongs to that set. So dapat makabalo gyud dapat ta na whether those particular things belong to a set. Kay basing magpahita ka kita nga dili na biya siya belong sa set tapos ato pa gayon siya gi-appeal. So unhon na to siya para ma-distinguish whether it belongs to a set or not. So we relate a member and a set using the symbol. So if an object x is an element of a set A, so kung belong ba siya an object x, for example, sa element set A, so we will write x is an element of A. So how diyon siyang pagkasuwat. And then if an object z is dili ba siya element of a set A, so we will write z is not an element of A. So how diyon siya. So next, so E denotes, so ini E denotes is an element of, or is a member of, or it belongs to. So element siya na belong siya sa nganha na set. So another is this symbol, it denotes is not an element of, so dili baya siya nganha, or is not a member of, or it does not belong to. So dili baya siya belong dinhaan na set. So again, when we see this symbol, it denotes is an element of or na belong siya dinhaan na set. And then pag ini is, it denotes it doesn't belong on that set. So for example, we have a set A of 1 with elements 1, 3, and 5. So makita nato that 1 is an element of A because makita nato na yaon siya sa set. And then 2 is not an element of A because waray element nga di sa set A nga 2. Only 1, 3, and 5. So again, this symbol represents is a member of or na belong siya. And then this symbol represents na wara siya ma-belong. So the set theory symbols. So again, we have first the set. So unhon para ma-identify siya, it should have a symbol curly braces. Naka-enclose siya. So a set, it is a collection of objects. For example, we have here set P. So may iya elements na 1 and 3. and B may elements na 2, 3, 9. And C may iya 3 and 9. Next is we have the intersect. So, we have the symbol pinabali nga U. So, A intersection B is equals to 3. It belongs to both set A and set B. For example, we have our A is equals to 1, 3, 5. And then next, we have our B. We have 3, 6, 7. So, when we say intersection, so, it belongs to both set A and set B. So, makita na to na what number belongs to both set A and set B is only 3. So, this is what intersection is. So, dapat both of the sets is yaoy ilaha or common sila. So, it belongs to both set A and B. So, next is we have the union. So, ang iya symbol is letter U. We have union. So, it belong to set A or set B. So, for example, we have A. So, we have 1, 2, 3, 4. And then we have the set B, which is 2, 3, 9. So, you will fuse or merge these two sets from the word union. So, isahon nimo siya. However, dili nimo pwede balik-balikon ang number nga you have 1, tapos duhaon nimo ka 2, duhaon sab nimo ka 3, kay duha, kay isa sa A, isa sa B. Dili. Isahon ra dapat nimo siya. So, for example, we have now 1, we have 1, so we have 2 from A and B, we have 3, and then we have 9. And then, dapat may 4 ini kung ga-declare kita ng 4. So, we have 1, 2, 3, 4, and 9. So, again, from the word union is isahon nimo siya. So, again, ang kalahian nila sa intersection is whatever value is the same, so belong to both A and B. So, that is what intersection is. And then, ang union is imuha isahon. What belongs to set A or B is i-union nimo siya. And the next is we have the proper subset. And then next is we have the proper subset. So in proper subset, so here the set a set that is contained in another set. So for example, we have two sets which are set A and set B. So it means that set A is inside set B. However, set B should be bigger than set A for it to be called proper subset. So dapat mas dako ang value ng set set B compared sa set A. And the next is we have the subset. So, the subset is a set that is contained in or equal to another set. So, for example, nganhi, so again, ang atoa set A is inside set B. However, pwede da sila duha same non-value. So, kung kaina sa proper subset, dapat ang set B is much bigger ang iya value compared sa set A, nga di sa subset is pwede da sila identical nan value or equal to another nga set. And the next is we have a not proper subset. So, sa not proper subset, a set that is not contained in another set. So, it means na this group doesn't fit neatly inside the other one. So, dili gayud sila makaigo sa ito na set. And then, we have the superset. So, set B include set C. So, it means na it contains, as long as yaon siya. It contains all the items from the group, from the set A and set B. Next is we have is a member. So again, we have the is a member. So this would be our symbol. So for example, 3 is an element in a set A. So it means that the item or the element belongs to set A. And then we have is not a member. So for example, 4 is not an element in set A. So wala siya sa set A na belong. So other concepts of set. So an empty set or not null set. So again, ang null set is a set that has no elements. So empty da siya. For example, we have P laong da siya. So we will call it as an empty set or null set. Bakante da siya. Next is the cardinality or cardinal numbers of a set is the number of elements in a set. So two sets are equivalent if they contain the same number of elements. So for example, we have 1, 2, 3, and 4. And then we have so two sets are equivalent if nag-contain sila same number of elements. So for example, 4 elements nga di sa P and then 4 elements sub sa set Q. And then ang two sets sub kay they can be equal if they contain the exact same elements, although their order can then be different. For example, nga di yakasunod siya and then nga di is wara siya magkasunod. However, they contain the same exact elements. So 1, 2, 3, 4 and then 3, 4, 2, 1. So yaon nga di sa Q, yaon sab sa P. So equal sila. And then N is the set of natural elements, so non-negative numbers. And Z is the set of all integers. And then Q, the set of rational numbers. Example, the one of the forms PQ, where P and Q are integers, with Q not equal to 0. R is the set of real numbers. So for example, we have describe the elements of each set. So we have here set A. Its elements are A, E, O, O. So A is an element of vowels in an alphabet. So makita nato na ang A is a set of an element. So again, the set A is composed of elements A, E, O. So therefore, A is a set of an element of vowels in an alphabet. So next, sa set B. So we have 1, 3, 5, 7, and 9. So B is a set of prime numbers. So pwede da ilaong nato siya. So B is a set of prime numbers. So again, the set B has an element of 1, 3, 5, 7, and 9. So describe the subset and the universal set. So in this example, we can describe the sets this way. So set Y is the universal set. So the set of vowels, so yay ato vowels, I, U, and the first 5 consonants in an alphabet. So set X is a subset of Y. So subset ining X sa set Y. So therefore, it means na all elements found here are coming from the elements Y. So mas dako ang value ng Y compared sa X. So that is the subset and universal set. So subset is a set whose elements are all members of another set. So the symbol, it means is a subset of, and the symbol means is a proper subset of. So again, kung makitaghaw ini na symbol, it means a proper subset. So ang isa ka set dapat much bigger ang iyaha elements or value compared to the other set. And then kung makitaghaw ini na symbol, it means is a subset of. So pwede da same ang ilaha value. So example, we have the whole numbers 0, 1, 2, 3, 4, 5, and so on and so forth. So set A are composed of elements 1, 2, 3, 1, 2, 3, set B, set C, and set D. So again, this is the universal set, which is W. So tanan ini sila nga diyaon sa set belongs to W. So tanan ini nga numbers yaon nga di coming from set A, set B, set C, and set D. So gikan yaon sila sa W. So since all the members of set A are members of set D, so A is a subset of D. So symbolically, this is represented as A is a subset of D. So tan-awon na to. So A daw is a subset of D. So because yaoy mga value nga yaon sa D, yaon sa A nga yaon sab sa D. However, it is note that A is a subset that implies. So subset sa A, C, D, because again there are values coming from set A that is present in set D. So note that A is also a proper subset of D. So again, proper subset siya since D has members that do not belong to set A. Symbolically, this is represented as A is a proper subset of D. So makita na to because 3 daan value ng A, and then ang D is 6 ang iyaha value. So mas dako ang value ng D compared sa A. Because again, when we say proper subset, so dapat mas dako ang value ng isa ka set compare sa isa ka set. So nga di, we can say that A is a proper subset of D. So since, so yadi, A is a proper subset of D. So since some of the members of set C are not present or not members of set D, C is not a subset of D. Symbolically, this is represented as C is not a member of D. So makita na to na there are some values that are not presented in D, such as 6 and 7. So since all of the members of set A are members of set D, A is a subset of D. So symbolically, this is represented as A subset B. So makita na to na same an ilaha value. We have 1, 2, 3, 1, 2, 3. So, although A subset B, since there are no members of set B that are not members of set A. So, A is not a proper subset of B. So, makita na to because same lang ang ilaha value, tapos waray pagayod lain nga yakasagol na other values. So, therefore, A is not a proper subset of B. So, any set is considered to be a subset of itself. So, no set is a proper subset of itself. The empty set is a subset of every set. The empty set is a proper subset of every set except sa mga empty na set. So, we will solve problem using the concepts of set theory, including the methods of Venn diagram. So, set theory has its own notations and symbols that can seem unusual for many. In this tutorial, we'll look at some solved examples to understand how set theory works and the kind of problems it can be used to solve. So, for example, we have a set of natural numbers and then a set of whole numbers. So, again, each object is called an element of the set. So, ini 1, 2, 3, 0, 1, 2, 3 element yan siya. So, the set that contains all the elements of a given collection is called the universal set, and it is called or represented by the symbol or represent as mu. So, tawagon na to siya na mu. So, for two sets, A and B, so A union B is the number of elements present in either of the sets A or B. And then N, A intersection B, is the number of elements present in both the sets A and B. So, N A union B is equals to NA plus NB minus N A intersection B. So this would be your solution if there are only two sets. So, kung 3 sets na, so this would be your solution. So, hanapon nimo ang value ng NA and then NB, tapos hanapon po ang value ng intersection or values that are present among these two sets. And then, i-minus nimo siya or subtract. So, for example, in a class, there are 100 students. So, yaoy kunoy 100 ka estudyante. And then 35, ganahan sila ng math, and 45 like English. And then 10, ganahan sila. So, how many like either of them and how many like neither? So, hanapon nato. So, again, the total number of students will call it as universal set. So, mu is equals to 100 since there are 100 students. So, ang gilaong, ganahan kuno ng math is 35. And then, ang ganahan ng English is 45. Tapos, ang ganahan in both are 10. So, we are able to identify the number of math students represented NM is 35 and then NA is 45. So, number of students who like both, yaon sa duha is 10. So, di ba ang gihatag kainan na equation if there are only two sets? So, amo ini an atua gamiton na equation or formula. So, first is we have NA plus NM minus NE intersection M, both pag mulong kitag intersection is both. So therefore, 45 since English, and then 35 for math, and then minus 10. So we have 70. So, and then the number of students who like neither is we have mu, which is 100, minus the number of students who like either English or math is 70 coming from here. So 100 minus 70 is we have 30. So therefore, the number of students who like neither English or math is equals to 30. So, haod yaon pagkuha sa Venn diagram. So, another example, there are 30 kuno ka students in a class. And then among them, 8 students are learning both English and French. So, 8 kuno ka students ang nag-study both English and French. And then a total of 18 students are learning English. So, if every student is learning at least one language, so at least kuno gatuonan one language. So, how many students are learning French in total? So, ang Venn diagram sa problem should look like this. So, we have our mu, which is equals to 30 students. So, every student is learning at least one language. Hence, there is no one who fall in the category neither. So, in this case, this would be our formula. So, again, gihatag niya among students, they are learning both English and French. So, ang gipanghanap da niya nga di is how many language are learning French in total. So, isa da ka language ang iyahagi hanap. At least one language. So, dili siya mukuan nga duha ka buok ay na neither. So, isa da. So, it is mentioned in the problem that a total number of 18 are learning English. So, this does not mean that 18 are learning only language. So, wala nagpasabot nga only English. Ang gihatag da sa word is are learning English. So, pwede nga nag-learn sila ng English, pwede sab nag-learn sila ng French. So, learning English da sa ang gilaong nga di. Kung galaong na only 18 are 18 students are only learning English, so nga di nato siya ibutang. However, kay ang gilaong da sa niya, kay 18 students are learning English, so amo da nan gigawas nato an value. So, only when the word only is mentioned in the problem should we consider it. So now, 18 are learning English, and then 8 are learning both. So, it means that 18 minus 8 is equals to 10. So, therefore, the value of the students that are only learning English is equals to 10. So, again, giminus na to ang value giminus na to ang value ng 18 which are learning English minus 8 nga nag-learn both. So, learn both English and French. So, therefore, it can be seen nga 10 are learning only English. So, we have here n mu is equals to 30 because it states that there are students in a class. So, we have 30, and then those learning English is only 10. Only English. So, therefore, N of E union F is equals to NE plus NF minus NE intersection F. So, first is we have the 30, which is our mu, plus the number of students who are learning English. So, we have 18 plus NF. So, wala pa iyaha value tungod kay amuan ato gihanap. Because amuan iyaha gipangita. How many students are learning French in total? So, wala pa yung value. Minus E intersection F. Yaton 18 minus 8 takaina. So, we have 8. I mean, dili 18 minus 8. I mean, the E intersection F is those students that are learning both English and French. So, we have 8. So, amo ini siya ang intersection. So, we have 8 and then 18 plus NF minus 8. So, we have, kung ato ini i-transpose, so, the value would be NF is equals to 20. So, what I mean is dili 18 minus 8 equals to 10. So, this NE intersection F is the number coming from those students who are learning English and French. So, this is 8. So, we have 8 over here. So, 30 is equals to 18 plus NF minus 8. So, kung we will do the transposition method, is we will get NF is equals to 20. So, therefore, the total number of students learning French is equals to 20. So, para makuha na itong value sa 20 is aminian buhaton. So, first is we have 30 is equals to 18 plus NF minus 8. So, 18 minus 8. So, plus NF. So, we have 10 plus NF. And then, isulod na to ang 30. So, we have NF is equals to 30 minus 10. So, therefore, we will be getting 20. So, again, the total number of students learning in French is equals to 20. So, the number of students who are learning English is 18, and then the number who are learning in French is 20.